By Chang-Min on G-raff, an elevating tangible block for spatial tabletop interaction.
Hello, I am Chang-Min Kim from the Department of Industrial Design at KAIST. The work was done with the help of my advisor, Tek-Jin Nam. The presentation will be about G-raff, an elevating tangible block for spatial tabletop interaction. With the help of large screens and multi-touch sensing technologies, the development of tabletop computing environment has accelerated. However, the interface for tabletop is still limited to the conventional 2D finger touch. Interfaces lack physicality and tangibility. Moreover, the proper applications and scenarios for tabletops are not fully discovered. To overcome these limitations, researchers have introduced several studies such as tangible blocks or 3D spatial interactions above tabletop with using handheld display or self-actuations. Tangible blocks associate the blocks with the information on the display. However, they are still restricted to surface-based interaction and is also limited in supporting full 3D interactions. There are attempts to use the open space above the tabletop display as a 3D spatial interaction, but with handheld display approach, there are constraints that it always occupies a user's hand when holding the display. And for actuation approaches, it requires cumbersome equipment which make it impractical for wide adoptions. For these reasons, as to design a new interface device for tabletop computing environment, we set our design goal as below. Create a small and graspable size tangible interface device and develop an interface device that maximizes the potential of 3D spatial interactions above the tabletop. Lastly, design the device and system that is practical for wide adoption. G-raff is a small tangible interface device that supports 3D spatial interaction on the tabletop display. Small display devices such as smartphones or tablet computer can be simply attached to the G-raff's head part. To create a small tangible interface device, we adopted rollable metal ribbon structure as actuation method. The structure was first introduced from the work Kinarils in SIGCHI 2011. With the help of this structure, G-raff can elevate its head part stably up to 350 millimeter, and also by putting the structure at both sides, G-raff can express the incline of the head within 45 degrees. For sensing the position and rotation of G-raff used some size grounded metal chip. This works both on IR type and capacitive type of touch display. This is a system configuration for G-raff. An important part of G-raff system is supporting a simultaneous data exchange between devices. And using the exchange data, software couples the display contents between smartphone and tabletop. Some graphic user interfaces had to be considered when coupling the two different displays. Pointing crosshairs were adopted to accurately map and guide the elevated display to the tabletop display. A vector arrow was drawn to express the incline of the head display. Applications for G-raff were developed and its usage can be classified into three key features, that is exploration, representation, and manipulation. 3D data exploration features contents on the elevating display according to G-raff's position and orientation. The head display shows an augmented information, such as blueprint of a building on the elevating display. User can use G-raff to navigate through building height or search through arbitrary plane to observe virtual 3D model. Tangible representation features a height change or tilt of a head part by converting digital data into physical movements. Navigating G-raff through the surface of the tabletop, the elevating head display can actively represent the height of a building or show the tangent plane of a 3D graph. Also, head movement can express other type of information. Information such as airflow in a 3D position can be expressed. Direct3d Manipulation features users to create or control the data in the 3D space. 3D bar charts can be digitally and physically edited by touch and slide down interface. Localized zoom is available when necessary, and user can knock on the screen to directly leave a notation, or draw a new sketch in an arbitrary plane. Giraffe provides a new type of interaction. In the copy and paste function, the buffer state of copied data can be edited in the middle of the copy and paste process through the head display. Based on the applications, a preliminary study was conducted with 6 participants with comparing the application with both using Giraffe and conventional mouse. Results show that with perceiving Giraffe as an extension of conventional mouse, participants easily understood the system and interface of Giraffe. Participants highly evaluated the unique experience on digital data being represented in physical way, and features such as creating or directly manipulating the virtual 3D data were also highly preferred. But at the same time, limitations of Giraffe were also found. We are addressing these limitations as a main discussion points. One of the discussion points is how to create a better connected use of multiple displays. For example, the changing height of display conceals certain portion of the tabletop display. We have used some GUI elements, however, it may be necessary to investigate other UIs and hardware aids, such as a screen size combination, for the connected use between tabletop and a smartphone. The other issue is a hardware improvement. One major challenge in the design and the user study was to provide stable, accurate, and fast vertical movement of a head part. The metal ribbon structure is compact and enables a large degree of height change. But depending on the weight of the display, the structure stability has changed and caused inaccuracy in high position. Comparing with other structures, optimal movement speed and structure should be refined. Lastly, Giraffe provides benefits of spatial interactions on tabletop. However, even in that situation, multi-touch can be often more efficient. It is necessary to further explore specific applications and contexts in which Giraffe can be most beneficial. To summarize, Giraffe is a compact, tangible interaction device with height controlling feature. With the previous discussion points being clarified, we believe Giraffe can be a new type of actively used 3D interface device for the tabletop computing environment. Thank you for your attention. We thank Jungu Shim for the initial design idea. We thank the Kai reviewers for giving constructive reviews, and we thank K-Valley Initiative and Mobile Platform Center for supporting our research. Thank you again.
Do we have any questions? So I have a question, which is, have you considered other things other than phones or interactive